Let me tell you my story. Small story, not a bigger one. It's not my biography. The reason behind this session, this topic, the psychology behind computer science. So when I completed my 10th class, got reasonably good marks. Not the marks you people got. Okay, not in 90s, not above 90%. I got reasonably good marks. But at that time, there was a lot of demand for government junior colleges. And I couldn't get a seat initially in MPC. Actually joined BIPC. I was also interested. So I joined BIPC. But later I found that I'm the only person among my friend circle who joined BIPC. All my friends are in MPC. So I decided to go to MPC. There was a little sliding and I joined MPC. But the point to be noted here is, though I joined MPC, so I had interest in BIPC, medicine also, particularly the psychology. I think now also I can understand people in a better manner. I strongly believe that if necessary, I can play a psychological game. Though I rarely play it, if necessary, I can do it. I'm confident about it. I read a lot of books related to psychology. And that's why I introduced this topic, the psychology behind computer science. Why this psychology? What kind of psychology is required? How you should think as a computer science engineer? So that we are going to discuss in this session. So the topic is the psychology behind computer science. Cognition. Cognition is how we acquire knowledge, store it, understand it, analyze it, and use it for different purposes. How we acquire knowledge, how do you store it in your mind, and how do you understand it, analyze it, and use it for different purposes whenever it is required. So we use our senses, our five senses. To acquire the knowledge. Definitely after acquiring it, we'll store it in our brain. So there is a subtle difference between mind and brain. I'm not getting into it, but I know because physically brain is available, let us assume that it is stored in the brain. And our mind or brain that can be broadly classified into two types. Conscious mind and subconscious mind. Conscious and subconscious mind. Conscious mind we use when we are awake. When we are not sleeping, we use the conscious mind. Whereas if we take the subconscious mind, we generally use it when we are sleeping. So automatically our subconscious mind may get activated when you are sleeping. Somebody asked Einstein, how you solved this problem related to relativity. He said, I had a dream and it is solved. What does it mean? I had a dream, it solved. That means his subconscious mind has helped him in solving the problem. See, whatever you listen, whatever you learn, they will not go away. People say you hear from one ear and it goes away from other ear. There is nothing. It's not like that. So whatever you see, whatever you hear, it goes and sits in your mind. It will be there. The only thing is you have to use it. You have to use it whenever required. So in future, whenever you have a problem, think about the problem and sleep. Not just the problem, think about different possible solutions and then sleep. In sleep, you may get an idea, then wake up and note down the solution. Don't wait for the morning. By the time you wake up, it will be gone. So wake up immediately and note down the solution. Sometimes for the very complex problems, you get solutions in sleep. So subconscious mind is more powerful than the conscious mind. So as human beings, how do you understand things? You understand things from your previous knowledge, what is there in your brain. So what is there in your brain? Based on that one, you try to analyze things at present and try to find solutions, and then those solutions will be stored. So it becomes the knowledge. So our knowledge is based on our previous knowledge. So there are two types of skills related to the brain: cognitive, non-cognitive. Cognitive skills, non-cognitive skills. Cognitive skills means they are the core skills where you use the brain directly. You will be using the brain directly. They are called as cognitive skills. Whenever you don't use the brain directly, but you may use the brain indirectly, then it is called as non-cognitive skills, otherwise called as soft skills. Both the skills are necessary actually. Both the skills are necessary. If you consider cognitive skills, attention, working memory, transitioning, emotional regulation, flexibility, self-control, communication, and problem solving are some of the cognitive skills. Attention, how attentive you are. Suppose somebody tells you a number, 10-digit number, 12-digit number. Are you able to capture it or writes it one digit at a time, erasing the digit immediately? Can you remember? Suppose imagine a mesh. Say 5 by 5 mesh. I put right marks in 10 cells. But as soon as I put right mark, immediately I erase it. Next, I put right mark in another cell. Like that, I put right mark and erase it immediately in 10 cells. Can you guess the where I put right marks? So that is attention. Working memory. So you will be always using your memory to work out the solutions. So you will be using your brain to work out the solutions to the problems. So like that, you have emotional regulation, self-control. Do you have this impulse control or not? Somebody scolds you, somebody makes you angry, somebody tries to play with you a psychological game. Then are you able to control or not? Are you able to control? See, a lot of things are nowadays psychology related. Mind games. People play a lot of mind games. You should be careful. So your impulse should be controlled. Impulse control is very much important. Impulse control. So whenever somebody motivates you, whenever somebody motivates you, you may commit a crime also. People can make you commit a crime. That's the power of psychological game. You should be able to communicate and then solve problems also. There are other skills called as non-cognitive skills, motivation, integrity, commitment, perseverance, etc. And also this team building, how do you collaborate, your emotional intelligence. They are also considered very important skills. Both the skills are required. For the human being. Thinking is the process of understanding the problem, generating the ideas, and decision making. So understand the problem, generate the solutions to the problem called as idea, and then take the decisions. All the three are very important. Understanding the problem, in fact, is more important than the solution itself. Also, you should be very good at decision making. Some people don't take any decisions. They will always postpone. So you should be good at decision making. So whenever you are taking a decision, there is some element of risk. but you should consider it. You should consider that element of risk and you take the decision, appropriate decision. So thinking implicitly implies using our rational to take decisions. You should always try to use your rationals. There are different types of thinking: creative thinking, critical thinking, divergent thinking, convergent thinking, design thinking. Creative thinking, critical thinking, divergent thinking, convergent thinking, design thinking. Also, there is another one called as computational thinking. Among these, for us, creative thinking is necessary. Creative thinking is necessary. Creative thinking may not be necessary at every point, but whenever it is necessary, it is the only possible solution. Creativity, creative thinking, and critical thinking is necessary whenever you are solving the problem. You should concentrate. Critical thinking is necessary. And also this, nowadays, this divergent thinking becoming very popular. Whenever you want to get innovative ideas, you have to go with the design thinking and also computational thinking. These things we will study briefly. Please note that I am not an expert in this all this thinking, but I want to make things open for you to learn more and become creative thinkers, critical thinkers, etc. So all this requires time and patience, practice. So creative thinking is a novel way of thinking. So as we discussed it previously, our knowledge or our analysis is based on what we know already, our previous knowledge. But sometimes previous knowledge becomes a constraint. Using previous knowledge, you may not find solution to creative problems or problems which are complex. There you require creativity. That means you think in a novel way. You have to think like a fool. Repeat, you have to think like a fool. Why like a fool? Why like a fool? Because a fool has no boundaries. He never thinks that something is impossible. He never thinks something is impossible. So that is the meaning of thinking like a fool. So today we may think that something is impossible, but tomorrow it will be possible. Maybe possible. So that's how we are progressing. Today we think something is impossible, but somebody tries to find solution to it, and we accept it. I think in one movie, Trikram Srinivas movie explains, అద్భుతం జరిగేప్పుడు ఎవరు పట్టించుకోరు, అద్భుతం జరిగిపోయిన తర్వాత ఎవరు పట్టించుకోవాల్సిన అవసరం లేదని. So you have to think like a fool, put no restrictions. Whenever you want to get creative ideas, put no restrictions, and explore all the possibilities. Don't stop thinking about any possible solution. And it is called as out of box thinking also. Out of box. The box is there. What do you mean by out of box? So all your facts, beliefs, fights, etc. put inside that box. Close it. Put inside that box, close it, and then think. That is out of box thinking. So put no constraints. All you know is inside the box, it is sealed. Now think. That is out of box thinking. Critical thinking is actually manual thinking. There are two types here, automatic and manual. So suppose a carpenter sharpens a wood. So initially he may be concentrating, but after some time it becomes automatic. He will be doing it mechanically. He will not be using his brain. So his hands will be automatically doing it. In fact, that's the reason why some people argue that mind is different from brain, and brain is in every cell. Mind is in every cell. Every cell can think, can inhale, can exhale, can live for some period, can die for some period, after some period. So our cells will be dying and new cells will be created. So in fact, every body part gets replaced. So if you consider 6 months time period, every body part gets replaced. New cells will come. In fact, cancer is nothing but a cell which forgets to die. If a cell forgets to die, then it becomes a cancer. Okay. So it's a manual thinking. It is a manual thinking. It is a manual thinking. So you should be continuously thinking about that problem only, that solution only, that procedure only. So critical thinking is examining things deeply, evaluating the pros and cons, etc. So critical thinking is not about improving your intelligent quotient, but is applying the intelligence to solve problems in a better way. Apply that intelligence to solve problems in a better way. Polya story of mental toughness. One story, which is an inspiration. Suppose you take a mouse, put it in a case. Usually the case is sealed from all the sides except that front side where there will be rods. But it cannot, through those rods it cannot escape. But as soon as you put the mouse in that case, or when it gets trapped, it tries in all possible ways. If there is a way to escape, it escapes. If there is any problem with any rod, if there is some more gap, it escapes. The moral of the story is try. You never know when you get a solution. You should be mentally tough to solve the problems. So you should have the toughness of the mouse. The problems which engineers are supposed to solve are not exercises. So usually in intermediate, maybe sometimes in BTech also, so your teacher will solve some problems and they will be given some exercise or assignments, whatever you call. And this exercise will be based on the problems which are already solved. So start solving those exercises. Fine. But please note that problems are also innovative. That means you may get a problem which is not similar to any of the problems which you have solved. It's a new problem. You study something, so it may be valid for 3 years, 5 years. After that, new things will come. You should be continuously learning. And the problems will also keep on changing. You have to find new solutions. So as an engineer, you are a problem solver, not exercise doer. Okay, solve problems. Exercises are only to orient yourself. Design thinking. There are 5 steps in design thinking. Design thinking is nowadays used to solve problems in an innovative way. So the steps are empathize, define, ideate, prototype, test. Empathize, define, ideate, prototype, test. Empathize means, so wear the shoe of the customer. That means you think yourself as a customer. Empathy. So you think yourself as a customer. Empathize. So look things from a customer perspective, not from your own perspective. From a customer perspective, because you are solving the problem for the customer, not for your own sake. So most of the problems you solve for the customer's sake. Define. That means define the problem. Formulate the problem. And then ideate. Ideate means find the solutions. Find all the possible solutions. After that, prototype. That means build a prototype or model of the solution. Model of the solution. Again, the purpose is to show it to the customer and gather some other requirements. After that, test it. Test it. So after testing here means customer should get satisfied, and is there a market or not? Is there a market or not? Is there a market or not? That is very, very important. Right timing. Right timing. So be careful. So be careful. These are the this thinking is generally used in entrepreneurship world, and it's slowly gaining importance. And many companies are actually allowing their employees to spend some 10%, 20% of them about thinking about these type of problems, new problems and new solutions. They're allowing their employees. For example, Mahindra allows their employees to think, to develop innovative products, and they can partner with the Mahindra itself and then market them. So if you have conservative mentality, and if you think that that employee should work for only for yourself, then he will start managing and he will never think creatively. So there will be no progress. Not a clerical work. Engineering is not about clerical work. Engineering is not a clerical work. Computational thinking. So it is a term coined recently. To solve problems using computers, we should think using computational thinking. So we require computational thinking. Think as a computer. Whenever you are asked to solve a problem, say addition of two numbers is think as a computer. So you are asked to solve to find the sum of the two numbers. So now I ask you, so find the sum of the two numbers. Now what should be your question? And now you are a computer. What should be your question? What are the numbers? First you have to know about the first number and then second number. After that you can perform this addition. So think as a computer. Put yourself in the place of the computer. And then solve the problem. Your program can be considered as a dialogue between the user of the program and computer. So Professor Janet Wing is the person who coined this term computational thinking. The simple definition: the set of concepts and strategies used by computer scientists to formulate and solve problems. So ones that are used by computer scientists. So you should use computational thinking. In fact, computational thinking can be used to solve problems other than computer related problems. You can solve many problems using computational thinking. So if you are more interested, you can go through her lectures. They are available on YouTube. So humans can solve problems using computational thinking. We cannot use computers to solve all the computational problems. So some computational problems we can solve using computers, some we can solve without using computers also. Though it is a computational problem, it doesn't mean that you have to use the computer. Some problems can be solved without using a computer also. And computational thinking uses decomposition, pattern recognition, abstraction, and algorithm as the steps. Decomposition, that means dividing the problem into sub-problems. And then pattern recognition. Okay, I have solved some problems previously. Is it the same pattern? Can I use that knowledge? Can I combine the knowledge of solutions which I used to solve some problems previously? So patterns will be there. Always try to recognize the patterns. Abstraction is actually taking the essential characteristics for the time being and neglecting the other things. Very, very important principle in the field of computer science. Abstraction is taking the essential characteristics and neglecting the other things for the time being. So whenever the problem is complex, you cannot solve it at a time. So we try to identify different levels of abstractions, and try to solve each abstraction, try to provide solution to each abstraction. Each abstraction provides some help to the another layer of abstraction. So like that you can solve it. So abstraction, the main principle. And you have to represent everything as a sequence of steps. That is nothing but the algorithm. Algorithm is nothing but the sequence of steps. So in summary, we require critical thinking. Whenever you are solving a problem, the computer science or not, it's a different issue, but critical thinking is required. Whenever the problem is new, then creative thinking is required. Whenever want to solve it, or whenever you want to represent it as a computational problem and use computer to solve it or use computational thinking, then you should definitely think like a computer, and then use computational thinking. So critical thinking, creative thinking, and then computational thinking. These three are important for a computer science student. So these are some of the references. Think Smarter. If you are interested, you can go through that book. Other books are also available. These are the references for the entire module. Not just for this session, for the entire module. So module 2. Okay, thank you very much for joining. With this, we end this module 2. Thank you.